Hello guys, welcome to my channel Brain Tech.
Today, in this video, we are going to study a topic which is related to complex numbers. That is expansion of sine raised to n theta, cos raised to n theta in terms of cosine or sine multiple of theta. Now, what is sine raised to n theta and cos raised to n theta? Means what? Sine raised to phi theta is there, so we will find in terms of sines of multiple of theta, or if it is cos raised to something, then we'll find in terms of cosines of multiple of theta. For this topic, the basic steps which are, first is x is equals to cos theta plus I sin theta, which everyone knows about it, and the inverse will be with a negative sign, which is cos theta minus I sin theta. Second step is, if x raised to n, then it will be cos of n theta plus I sin n theta, that is De Moivre's theorem. 1 upon x raised to n is cos of n theta minus I sin n theta. Third step is, if we add, then what we'll get? X raised to n plus 1 upon x raised to n. Then it will be 2 cos n theta. Means whenever a cos term is given in the question, then straight away use x plus 1 by x. And if they give a question as sine raised to something, then straight away use x minus 1 by x. Fourth step is binomial theorem. If you don't know binomial theorem, click on the I button above, see the video, you will get your concept clear. So, let's start with an example. The question says, expand cos raised to phi theta in a series of cosines of multiple of theta. So, the solution for this sum, your first step is x is equals to cos theta plus I sin theta. Therefore, 1 by x will be what? Cos theta plus minus I sin theta. Your second step, you can directly write it as, this is a cos term, means you will add. So it is x plus 1 by x will be 2 cos theta. So therefore, if it is x raised to n plus 1 by x raised to n, then it is 2 cos n theta. So remember this, if it is x raised to 5 plus 1 upon x raised to 5, then it will be 2 cos phi theta. So remember it. I've directly used as the binomial theorem. So we'll write binomial theorem. Now how to use binomial theorem? Now cos raised to phi theta it is. So for cos term, 2 cos theta the whole raised to phi, which is equals to, if it is a cos term, we'll write it is x plus 1 by x raised to n. Raised to n, here n value is what? Phi. Now we will expand this in terms of binomial theorem to solve this kind of binomial theorem. So x plus 1 by x raised to 5. We will expand this in terms of binomial theorem. So I'll use 3 steps. In first step, I will expand x value. In second step, I'll expand 1 by x value. And in third steps, I'll put the signs. So just see. Always remember, the first value will go on decreasing and the second value will go on increasing. Now how? It is x raised to 5, then it will be x raised to 4, then it will be x raised to cube, then it will be x square, and it will be x. Second value will go on increasing. First value you have to skip, write it from the second place. It is 1 by x into 1 by x square into 1 by x cube into 1 by x raised to 4, and it is 1 upon x raised to 5. If it is in the question cos term, then everything will be positive. I'll put the numbers. Now for the numbers, you have to remember about the Pascal triangle, which we have talked in the previous video of De Moivre's theorem, expansion of sine of n theta and cos of n theta. If you don't know how to use Pascal triangle, then kindly click on the I button. You will understand how I have used Pascal triangle in the sum. So for raised to 5, it is 1, 5, 10, 10, 5 and 1. Now if anything is getting cancelled, then we'll cancel it. Here this 1x and here it will be 3. Here 2 will go, here it will remain 1. Here this 2 will go, here it will remain 1. Here this 1 will go and here it will remain 3. And here nothing. So I'll bring like terms together. Here it will be x raised to 5 plus 1 upon x raised to 5, which I have already written. I'll just write it out for my convenience. Then it will be plus, I'll write it 5 out. It is x cube and it is this. So 5, here also 5, here also 5. 5 is common. I'll write it as x cube plus 1 upon x cube plus 10. Here also 10, here also 10. So here it will be x plus 1 by x. So everything gets cancelled. First I'll copy this, or the answers we got it as. It is 2 cos theta the whole raised to 5 is equals to x raised to 5 plus 1 by x raised to 5 plus 5x cube plus 1 upon x cube plus 10 of x minus plus 1 by x. So here it is 2 raised to 5 cos of 5 theta x raised to n plus 1 upon x raised to n. I said it as it is 2 cos n theta. So I'll say it is 2 cos 5 theta plus it is 5, it is 2 cos 3 theta plus 10, it is 2 cos theta. Okay, so what I will do, 2 raised to 5 cos raised to 5 theta, 2, 2 and 2 will remove 2 common, will write it as remaining cos of 5 theta plus 5 cos of 3 theta plus 10 of cos theta. Then what we'll do, we'll cancel 2 and 2. So here it will remain 4 and this 2. So it is cos raised to 5 theta is equals to 1 upon 2 raised to 4 and remaining as cos of 5 theta plus 5 cos 3 theta. So you got the value as 1 upon 2 raised to 4 cos of 5 theta plus 5 cos 3 theta plus 10 cos theta. So this is the answer for expansion of cos raised to 5 theta in terms of cosines of multiple of theta. So this was a solution for cos raised to 5 theta. I hope that you have understood the steps very clearly. If you have any query, let me know in the comment section. Do like, share and subscribe, and also press on the bell icon for the future videos.